Hello, my name is Shane Eaton. I'm a medical student with a master's in neuroscience, and with the support of Alberta Tech, student chapter of Neurotech X at the University of Alberta, I would like to present our challenge, RemBRAINdt, Generating Art from Live Brain Data. Brain-computer interfaces, or BCIs, are devices that connect the human brain directly to computers. The most common type utilizes electroencephalography, or EEG, which records the electrical activity of the brain through the skull. With recent advances in such technology, BCI devices are becoming cheaper and more sophisticated. As they become affordable and enter the consumer domain, the need for BCI apps grows. The challenge we present is the development of an interactive EEG-based application that generates customizable and dynamic art influenced by the user's emotional state. The initial business plan for this application would be a software as a service for use at private and public fundraiser events. We've already developed an award-winning minimum viable product we call RemBRAINdt, which won the People's Choice Award at the Neurotech 2020 hosted in Russia. Here you can see a self-portrait of RemBRAINdt wearing his little EEG cap. He was surprisingly high-tech for the 1660s. But anyway, back to business. Part one of the solution would be to enrich our basic framework with additional features and further develop it into an end-to-end software as a service application. These features may include gathering user data, setting up an integrated online presence, and incorporating an automated or semi-automated payment, shipping, generation of physical art pieces derived from brain data, such as a 2D painting or a 3D model. Part two would involve the development of a business plan for commercialization of the application, establishing early adopters, constructing a supply chain, and developing a funding plan. Our challenge requires three domains of expertise: computing science, graphic design, and business. RemBRAINdt uses machine learning powered by Google Cloud Computing to interpret EEG data and convert it to dynamic artwork. First, baseline EEG data is recorded from the user as they are randomly exposed to emotionally charged words. For example, hostile would invoke a negative reaction, whole a neutral reaction, and sour a positive reaction. The word lists we use and the mode of presentation are both widely used in psychological research. This baseline data is then used to train our deep learning algorithm to be able to classify the emotional valence of the user's live EEG data. As machine learning is computationally intensive, the training is offloaded to Google Cloud Computing in order to minimize the device requirements. For those who are in graphic design, the user has the option to customize how the art will be generated. At its current stage, the options are limited to colors and line widths, but this has a lot of potential for enrichment, such as introducing different art styles, even switching from painting to a sculpture mode. Development of this aspect would be the key to the success and replayability of RemBRAINdt, and is where a graphic designer would shine. Finally, on the business side, once everything is set up, the trained machine learning model interprets the user's live EEG data and generates dynamic art. At any point, a snapshot can be taken from which a high-quality print can be made available for purchase. This would be offered as a software as a service, which could be brought to private and public events. Business expertise would be invaluable in addressing this aspect of our challenge. Working on this challenge would provide team members the opportunity to launch and innovate a student-made product with partnership roles offered to those who make significant contributions. All contributors on the project would receive acknowledgement within the app and all platforms. And by working on this challenge, you would become a pioneer in the emerging brain-computer interface industry. Our application is built on Python with PyQt5 and TensorFlow. Ideally, team members would have experience with Python, including PyQt5, TensorFlow, and EEG data processing, and at least one team member should have experience in art and design and one in business. Our ideal team would consist of 3 people experienced in computing science, 1 in graphic design, and 1 in business, a minimum time commitment of 6 hours per week. Thank you, and I'm happy to answer any questions.